So this is the animation that we'll be recreating today in some sense. And yeah, it's finally happening and we'll be using Houdini for a change in this one. This is the first Houdini tutorial in this channel and hopefully it won't be the last. So without any further ado, let's get started with it. Alright, so believe it or not, it is almost 2 a.m. On my end. But alright, so here we are in Houdini. So let's start by hitting tab and adding in a geo nodes or a geometry node, whatever it's called, and let's just type in. And before I start explaining each and everything, let me just create a quick setup so that I can, I have a base to start with. So the first thing I'm going to do is add a circle node right over here. And right now my parameters are not my parameters are not here, so let me just quickly hit B and they will be there. So if any of you are facing that problem, it's there right for you. All right, and so now here we have a circle, so I'm going to reduce the divisions down to 3 and I'm going to set it to lie on the ground. So there we go, it is looking perfect. And I'm going to set this type to be a primitive, or actually a polygon, because yeah, we need the divisions, and it's going to be a closed arc. So if we take a look at the geometry spreadsheet, we have 4 points. So nope, gotta be a just closed. Let's see. All right, so 3 points, because that's all we need. And yeah, then the next thing I'm going to do is create a tube, and we'll take a look at its properties later on. So but at the start, let's just select end caps, so let's set it to be primitive and change the height to whatever you like at this point. We'll get to that in a sec, but let's just add in a copy to points node, which should be copied to points. There we go. And it requires 2 inputs. The first one will be the geometry that we want to copy, and the of course second one requires the points on which we should be copying. So let's just see that. And all right, so that's weird. And the reason why this is happening, because in the properties, if you take a look, we have transform using target point orientation enabled. So if we uncheck that, we should be getting this. And now from this point on, you can manipulate these settings that we have over here. But to give you the exact settings, or you know what, before I even start with the settings, let me just quickly talk about what the hell I am doing over here. So if we quickly take a look at the video, or the original video, you'll notice that we have these 3 tubes, right? So it's this 3 tubes, stretchy thing, whatever you want to call it, but we have those 3 of them. And basically this is exactly how they started, right? So if we take a look at the video, they are super close to each other. So obvious. Okay, if I can switch, there we go. So to make them closer, what we can do is set the radius of the circle, which at this point is the uniform scale. We can set it down to something low, and to get even precise with the scale, I'm going to give you the exact radius or the uniform scale, which in my original animation it was 0.2. So this means now we have to change the radius of the tube as well. So what I did was, which was weird, but I ended up turning up the radius and then changing the radius scale itself to something low. So 0.17, I think it might work for you guys. Again, experiment with it. I ended up using 0.65, so not that far. All right, and the height of course depends on you. So let's try, and yeah, I think something like this. I ended up using 0.03, so they were they're small. And again, as we proceed further with the animation, different settings, each and every setting will give you a very different outcome. So at the end of the day, you'll have to come back over here and change a few things in order to get your desired result, basically. But that's it. All right, so now we have the initial stage ready, and the next thing, if you can take a look at the animation, is to create the motion, basically. And I have my headphones on and that music was playing behind, so I had to take it off. But anyway, sorry for the delay or the interruption. But basically this animation right here, and I realized I can mute this. So the animation motion, right? So if you take a look at it, it is rotating clockwise and then it rotates anti-clockwise and then it keeps on repeating that. All right, so the basis or the basic of the animation motion is clockwise rotation and then anti-clockwise rotation. All right, so that will be the next step in this tutorial. And let me just turn off this music because it is playing in my headphones, which is something I should have considered while doing this. So it is kind of weird when I record it and then this music is playing. So yeah, just gonna mute that over there. But yeah, so that's the motion that we are after, and then we'll create the geometry, this tube-like, snake-like thing that we have over there. Still, I have no idea what to call it, but anyway, so the way to do that is actually I ended up using attribute Wrangle. All right, so yeah, I will have vex here and there. I mean you can achieve it with a transform node, I guess, but yeah, vex, the code is pretty easy, so nothing big to worry about. And you know, in general, it's coding is a bit fun for me. So anyway, so the way to rotate when it comes to vex is there are actually a couple of ways, but the one we're going to use is called the rotate function. So if we just type in rotate, this function right here is what we're going to use, and it requires basically 3 parameters, right? I mean, it requires a bunch of parameters. If we just click on the rotate and hit F1, the help page will appear, and you can see that it can work with a lot of parameters, but the one we're going to do, or the one we're going to use, is this one. So let me just quickly type in the values that we'll need. So the first thing that we'll need is a matrix, right? And it has to be an identity matrix. So IDENTITY, if I can spell it. There we go, identity matrix. That's the first parameter it will need, and it's pretty easy to create, so I'll just show you in a sec, so don't worry about that. And the second thing that it requires is a rotation, or yeah, the rotation amount. So how much do you want me to rotate? And the third and the last parameter is the axis. So on which axis, if I can type today, which axis do you want me to rotate? So these are the 3 parameters that it requires. And then lastly, what we need to do is take our position and we need to multiply it with the matrix that we just created. All right, so these are the only things we require, and that's it. So I'm not going to pretend to understand the matrix stuff, the stuff as well, but surprisingly it's pretty easy. So the way to create this identity matrix is to type in matrix 3, and we need to give it a name, so M, and it is just ident. Yeah, there we go. So that's really it. That's how you create the identity matrix. And if you remember in school, if you've paid attention, for some reason I did it because I found this chapter pretty easy. But basically, identity matrix, as you can see in front of your screen, is this is it. Yeah. So, but yeah, you don't really have to know what's going on over here. I certainly don't. I mean, it would really help, but in this case, just remember this is how you create the identity matrix. And since we've created that, let's use that over here. So let's put M over here, and let's put M over here as well. All right, so that we have covered. So the next thing that we need to do is set the rotation amount, which is going to be a float, right? And you can name it whatever you want, and I'm just going to name it angle, or not angle, yes, not angel, angle. And that angle literally could be anything. So right now I'll just set it to something like 20. All right, and yeah, that's it. So let's just use that over here. So ANGLE. And the last thing that we need is the axis. All right, so now axis it consists of 3 floats, so X, Y, and Z. So it is going to be a vector. And again, I'll just name it axis, but you can name it whatever you want. And to create an axis, what we need to do is type in like the curly bracket, and then we need to specify which axis. So basically 0 means no and 1 means yes. So we have 3 axes, X, Y, and Z. All right, and let's just close this. And we want it to rotate on the y-axis. Okay, I mean it would actually depend on you, like you can even rotate it on this z-axis or x-axis, but in this one I want it to rotate on the y-axis, which is the up axis in Houdini. So this one will be 1, and the rest, since we don't want it to rotate on the x and z-axis, it is going to be 0. You can even create a channel vector, a parameter, so that you can control it from the outside, but I know that in this case I want it to rotate on the y-axis. So yeah, this is all it is, right? I mean, this is the basics of this, and we're going to modify this angle a bit, right, the rotation amount. But yeah, so if I hit apply and accept, you'll notice that if I disable it, which is this, right, you can see that it is changing its position or the rotation, which means it is working. So what I'm going to do is actually, instead of typing in a number, I'm going to use the frame attribute, and the frame attribute basically gives us the value that we have over here in the timeline. So if I hit apply and accept, and if I hit play, you'll notice that it just goes bonkers. And the reason for that is because we have this real-time toggle disabled. So if we enable it, this will now play in 24 or 30 frames, whatever we have going on over here. So if I hit play now, it still is rotating pretty crazy. And the reason for that is because Houdini expects the values in radians, or when you think about it the other way around, it is that we think, or we are inputting values in degrees, and we think that Houdini is interpreting them in degrees, but basically it is not. It is interpreting these values in radians, and 1 radian I think is 57.95 something degrees, right? So that's a huge thing. So what we can do is, well, just convert these values to radians. So the function to do that is just simply radians. So RADI, yeah, there you go, this function right here. So hit apply, accept, and now if we hit play, you'll see that it goes smoothly. Yep, but unfortunately we won't be using the radian function in this one, but yeah, I just wanted to let you guys know that it's a thing, and this is why it's happening. So now I'm just gonna hit apply. Okay, equal to sign, no need for two equal to signs. All right, cool, thank you Houdini for letting me know. All right, cool. So now if we hit play, it is doing its thing again, and that's super cool. All right, so now the next thing is, how do we get this back and forth motion that we have going on over here? Well, it is actually pretty easy. All right, so the first thing that we need to do is slow the shit out of this. All right, so that's the first thing we'll do, and then later we'll proceed to this back and forth motion. Okay, so the first thing that I'm going to do to slow this down is I'm going to remap this. All right, and the way to do that in Houdini is basically just use the fit function, and the fit function requires a few parameters. So it requires the value that we want to remap, okay, and then it requires the current minimum value, then it requires the current maximum value, and once we have fed in these values, we can now set the new minimum value and the new maximum value. So the current value, or basically this value, is going to be angle itself, because this is what we want to remap. And well, what is the current minimum of the frame attribute? Well, it is going to be 1, of course, because that's when the animation starts. And the current max, well, the current max is going to be 240, because that's when the animation ends. But 240 is a very subjective number, meaning that if I want to, I can switch it to 180 or 20 or 30 depending on my liking. So does that mean I have to go over here and change the value? Well, not really. What we can do is type in $FENT. So this is an attribute that fetches the end frame of your timeline. So you don't have to type in anything new. You just type that in and it will just fetch that value over there. And so the new value in this one, so sorry about that, but all right, so let's go on. So the new value in this one is going to be 0, right? Because I want the rotation to start from 0 degrees, and the new maximum value. So this one, it of course has to be in radians, so we have to think from that perspective. And I want it to complete, well, basically we want it to go back and forth, right? But let's start slow. So basically what we want to do is complete one whole rotation, and that is 360 degrees. So 360 degree in radians is actually 2 pi. So to type that, all you have to do is a $pi, capitals, times 2. If I can type times 2, that is all right? So now if I hit apply and accept, and if I hit play, you'll notice that during this entire animation, our tubes complete one whole rotation. And funny enough, they loop. So that's one cool, but it is a bit slow. So what I can do is, instead of this fn, so this 240, I would like to divide it by 2, so the whole thing is a bit faster. There we go. So now that is it is just faster. And oh, all right, cool. So one more thing I need to explain. As you can see, after frame 120, the animation just stops. All right, so the reason why that happens is because, as you'll notice, the minimum value, or the maximum value is set to 120 because we divided the end frame, which is 240 divided by 2 is 120. And the reason why the animation doesn't continue is because this fit range, right, this fit function is clamping the values. So basically after frame 120 there will be nothing. All right, so it is getting clamped. The whole animation is getting clamped basically. So the way to unclamp is to basically use another function called efit. So efit is like the fit, it's basically the fit function, but it doesn't clamp. All right, so it's just as simple as adding in an e in front of the fit function. All right, so let's hit apply and accept. And now if I play after frame 120, as you'll notice, it is still continuing. So that is all cool. So now the next step is to get the back and forth motion. All right, so, and the way to do that, or the way I ended up doing it, is I ended up using the sine function. So before we start typing the code, let me just quickly take a detour and explain what a sine function is. So let me just quickly create a new layer over here, and imagine, beautiful, Jesus Christ, what the heck was that? All right, so yeah, that was straight. So let me just draw that. Whew, didn't know I could hold shift and draw a straight line in Photoshop, but Jesus, the fuck was that? All right, yep, cool. So this is your graph, all right, and this right over here is the beautiful, all right, so let me just quickly draw it. Yeah, is our beautiful sine curve, and the sine curve basically goes from, actually flows below over here, I think, depends actually, but let's just start over here. So it has a value of 0, and it goes up to a value of 1, and then it goes down to a value of -1, and then it goes down to a value of 1, and then -1. So this is the journey of the sine curve, and you can dive deep into it. I'm not really a mathematician, so I don't really I don't really know if I can explain it any better. But basically, if we feed in our current values, they are going to be remapped to these values right over here, which is basically 0, 1, -1, 1. So that journey is going to keep on going. And if you take a look over here, there is a pattern that there's 1, then it goes to -1, then it goes to 1, and then it goes to -1. And now if you remember our animation over here, which is this one, right, it completes one whole rotation. So basically it completes 360-degree, right? So that's what it does. But if you feed that into this, it should basically have the same behavior as 1, -1, 1. So it should be like 360 degrees, -360 degrees, 360 degrees, -360 degrees. So it should keep on doing that. And with that, we should hopefully achieve this back and forth rotation animation that we have over here. All right, so fingers crossed. Let's click over here, Control E. Yeah, Control E to bring that up. I'm sorry if I didn't mention it before, but yeah. So after that is done, let's type in angle again. Make sure to not type angel and angle. And the way to use the sine function is to just type in sine, and it requires only one parameter, which is the value itself that you want to put into the sine, which is going to be our angle right over here. So now if I hit apply and accept, and fingers crossed, let's hit play, and it does that. All right, so what the heck is happening? Well, it is doing what we want, so it is going back and forth and back and forth. So that song and dance it's there, but it's not exactly completing those 360-degree rotations. All right, and I'll give you a second to basically figure out what the heck is going on. And yep, second is over. All right, so the reason why that is happening is because, as you recall, the sine function, it only has, like, it basically converts all the values to a range from 1 to minus 1, 1 to minus 1, and basically 1 in terms of Houdini is 1 radian. So basically it is rotating 57 degrees. So from 57 degrees to minus 57 degrees, and that is what is going on. All right, so well, how do we fix this? Well, it's pretty easy. We just have to remap the value again, and yep. So let's just go over here and add another fit, or you know what, I'm just going to add an e fit because yep, pretty sure I don't want anything to clamp, and you already know what it wants. So basically we want to remap the angle value, and its current minimum is, well, -1. That's what it is. And then 1 is its current maximum, and the new, well, again, it's going to be 0 and $pi times 2. So now if I hit apply and accept, and if I hit play, fingers crossed, yep, it is completing a 360-degree rotation. Or maybe it's not. I mean, it's very hard to tell right now, and as you may have seen, it sort of the loop is incomplete, so it doesn't exactly loop. Or does it? Let me check. Yep, it doesn't exactly loop. All right, so why do you think that is happening? I'll give you a sec. All right, second is over. So the reason why that is happening, or at least the reason why I think is happening, is because actually when we start feeding in these values to the sine curve, right, it starts with 0 and then it goes 1 and then -1. So technically when it starts, 0 is the current minimum value. So if I type in 0 over here, right, and let me just check if there are any errors over here. All right, looks good. All right, cool. So now if I hit apply and accept, and fingers crossed, if I hit play now, as you can see, the rotation, it actually has increased. And now let's check if it loops. Nope, it doesn't. And I think it's the end frame issue actually. If instead of using 240 in the timeline, so I'll let that stay 240. But if I set this to something like 239, and now if I hit play, yep. All right, so that works just fine. All right, cool. So I guess that was, so I think even if we set -1 over here, it should work fine. But in my original animation, I actually ended up using 0 itself instead of -1. So -1 might actually be the technically right answer. But here's the thing with fit ranges, right? What you can do is whatever the original range is, you can just take a part of it and then remap that, and yeah, you just use that, and whatever the remaining part is that you left out, well, you just left it out, so it doesn't really matter. So 0 is what we'll be going with. And if you want, right, you can even mess with these two parameters over here. Changing one or the other will drastically change the animation, and we'll see that in a second. All right, but yeah, so basically this is the animation that we have going over here, and it is pretty cool. And now begs the question as to how the heck are we going to duplicate this geometry, or basically how the heck are we going to create this jelly-like effect, right? Well, again, a lot of ways out there perhaps, but the one I ended up using it's pretty weird, I guess, but I ended up using a solver. So let's drag and drop in a solver over here, and a solver basically, let me just arrange that. All right, so no cities for now. Excuse me. All right, so basically a solver, what it does is whatever you put inside of it, it will just keep on repeating that thing over and over again. So if I take the previous frame's data and if I add a transform to it, right, and make sure that it's set to wave and the render flag is on, and if I translate it a tad bit up, all right, and now if I go up, select the solver, and let's just zoom out a bit, and now if I hit play, you'll notice that it just keeps on going forward, because that's what it does. It takes the previous frame's data and basically it applies to the current frame. And I mean, guess there are better explanations of the solver out there, but basically just think about it like this: it repeats whatever you tell it to do, all right, and mostly from this input, not these rest inputs. These are basically just there to bring in the outside geometry. This input is what will allow you to do the repetition thing. So how are we going to use this to do this? Well, there's one thing I would like you to notice, right? As the animation proceeds further and as this new geometry you see as it exits, you can see that it keeps on scaling. All right, so there is a zoom effect going on. So as this geometry proceeds further to grow, the rest of the geometry, it keeps on increasing. All right, so these are two things that we need to take care of. First, that the geometry, let me just reset this actually. All right, so that's it's on the ground. All right, so first let's start by actually creating the geometry, and then we'll see how to scale the whole thing. All right, so the first thing that I'm going to do is bring this translate down to something really small. I think I'm going to bring it down by negative 0.006. This is the value that I ended up using in my original animation. And then what I'm going to do is from this input 1, right, which is basically our original geometry, right? So that our geometry which is directly fed it into this inputs. So what I'm going to do is add a merge node, all right, and I'm going to mix these two geometries, or basically merge them together. So now you'll notice that we have two geometries overlapping on top of each other. All right, and now since this geometry, right, so we have the previous frame geometry, which is, as you saw, it keeps on repeating that, and then on top of that, if we add the current geometry, we should be getting a lot of geometries out there. So let's check that out. So I have my solver selected, reset the simulation, and now if we hit play, yep, so as you can see, that is what the solver does. So we have on each frame new geometry is being created, and with the help of this previous frame we are able to push it down. So that's what's basically going on. I guess I don't know if I did a better job of explaining that, but yeah, that is how you do it. And basically that's how you would do the scale animation as well. So in this case, the scale increases, as you can see, as it keeps on growing, the rest, or the, yeah, basically the rest of it increases in scale, right? So there is an increase of scale. So yeah, let's just select this transform and change the scale. So in my original animation, 1.011 was the scale I used. So make sure the render flag is set on this merge node. Let's just reset the simulation, zoom out a bit, and fingers crossed, let's hit play. And we are getting this effect. All right, so it's not exactly there yet, and it really it does look bad. And one of the reasons why this is happening is because the scale is a bit too much. And here's something you should know. Like I said earlier, even tweaks to certain parameters will drastically impact how this animation looks. So for example, I know the reason why this is happening, right? So I know why we are not getting this result, and that is because the scale is a bit too much. So what I mean by that is, if I add a transform after the copy to points, because if I change the scale after the solver, it will change the scale of the entire geometry and not the tubes individually, right? So if I add a transform over here, and if I set the scale to something like, I don't know, I guess, wait, 0.3 and 0.3. So I just want to squash it on the X and the Z axis. Let the Y be the same as it is, and then let's go to the solver and let's just reset the simulation. And now if I hit play, you'll notice that the difference is night and day. So we went from having a fat geometry, so let me just disable that quickly. So we went from this to this. So this is how big of a difference little tweaks can do to our geo. And one of the things that can also help is, as you can see on the first frame, we only have two geometries, right? So it's not exactly good. I mean, it depends on what you want, but what you can do is on the solver we have a start frame. So if I set this to like something in the negatives, something like it's minus 100, you'll see that the geometry automatically, okay, gets created for us. So that way it is just better. We can basically make decisions faster. And it solver basically it does the calculations. It basically starts doing the calculations that it has to do in here from minus 100 frame, which is here. So that's the logic behind that. And this is the geometry that we are getting. All right. So to get the result that I actually got in the original animation, what I actually ended up doing was in this rotation, right? This rotation thing. Didn't mean to write R. So Alt E. Over here in the first remap thing, I actually ended up using just pi. So not 2 pi, just pi. So if I hit apply accept and go to the solver, reset simulation, you can see that it just smoothed out the whole thing. Which again takes me back to the point where I'll say even small tweaks to each and every parameter over here will drastically change. So currently I really didn't want a lot of folds over here, right? But if you want more folds, what you can do is simply use 2 pi and just go over to the solver, reset the simulation, and there we go. So the geometry is more closer to each other. But yes, I am happy with just the pi thing, and it just works out for me. All right, so there we go. So now we have our geo, and we actually have a problem with the geometry, and not the geometry per se, but the geometry that is being created. So if I hit play, you'll notice that the animation, it works just fine. But the other thing that is concerning is that the geometry keeps on increasing, and this is going to be, I mean, as we proceed further, this geometry will get a lot heavier. All right, and how do we tackle that? Well, we basically, it's pretty simple. We just basically tell that if I just hit 3 on the keyboard, or it's a side view. So on the y-axis, right, if a point is below 1 or 1.5, so -1 or -1.5, just delete the geometry. And that's what we need to tell. So the way we do that is by adding in an attribute Wrangle node, if I can type today, and it's like, it's what we said. So if, right, and then we need to mention what we need to say. So if the position on the y-axis, right, so at p.y is less than, all right, yeah, it's less than -1.5, and then open curly brackets, we need to delete the point. So hit tab and remove point is the function, and it basically requires 2 parameters. So it requires the from which geo handle should we be doing this, so it's going to be 0, and then the number of points. It requires the point data so that it can evaluate and do its shit. So the point data is at ptnum, so this is what contains the point number. And then if I'm right, which doesn't happen a lot, apply accept, there we go. So that is created, that's just deleted. So if I play, as you can see, any geometry that goes below -1.5, it will get deleted. So yep, that's it. So let's just press 1 to go to perspective view, and as you can see, our geometry is ready, and it is, yeah, it is what it is. And if again, I'll just mention it, just play with this attribute triangle over here that contains the animation. This will really affect the result. So yeah, spend a lot of time over here to get exactly what you want. All right, so the next thing is we need to convert this mesh that we have to something that looks like this. And how would we go about doing that? Well, again, not a Houdini expert, but what I did was I basically converted this to a VDB. So VDB from polygons, there we go, converted that, and I think I set the voxel size to something 0.05, yep, something like this. And then I added a VDB smooth, so VDB smooth SDF, this one, and then that just basically smooths the VDB, and then all we have to do is convert the VDB. So convert VDB, and we need to convert it to polygons. So that's it. And I'm going to set the voxel size to something like 0.05 for tutorial 6, 0.1. Let's just go 0.1. All right. And yeah, this will make a difference, but not right now, because I do have to explain another point, and that is that, well, we are doing this whole VDB shit, but it's actually merging our geometries, and we don't want that. If we take a look at the video, these tubes, or this whatever jelly thing is, they are all individual pieces, right? So how would we do that? Well, the idea is simple. What we need to do is basically separate each of these tubes individually and then apply this whole thing. Well, now the question appears, how would we separate them? Well, you can add another attribute Wrangle and then type in the code like, hey, whatever is whatever this does or that does, or with basically, I don't know. I mean, I don't even know how you would do that with an attribute Wrangle from this point on. But what I ended up doing, which was pretty clever actually. Well, so let me just explain that. We have a few stages to this animation, right? So first we create this points, and then we transform it to make it smaller. Then we do the animation on it, right? So over here, the animation, and then we use a solver to duplicate the geometry, or basically create more geometry, and then we delete the geometry below at a certain point. So these are the few stages. So this stage is where the geometry is created, and this stage is where the geometry is replicated, right? So now, if we were to separate, right, or group objects at this stage and then feed them in this duplication stage, they should have their each and individual groups. All right, so hopefully you guys are getting my point. So basically what I'm going to do is select each and every individual points over here, right, or these tubes. I'm going to select them individually, group them, and then feed them into the solver, right? Then the solver should assign this newly created geo the same group, and then we can use that to basically isolate and give them this effect individually. All right, so that's the plan. So I'm going to disconnect this for a while because, well, I just don't want them to compute anything for now. All right, so just keep them aside somewhere here so that I can see it. All right, so how would we go about separating this? Well, it's pretty easy when you think about it, because over here you'll notice that even though we have a bunch of primitives and we have a bunch of faces, at its core they are points, right? We are instancing this tube right over here onto the points of this triangle, right? So basically, if we take a look, if I middle mouse click on it, we have 3 points, 3 primitives and 3 vertices. So we have 3 points. And if we take a look at the geo spreadsheet, which is right over here, so if you are seeing something weird, just make sure that you have selected the right node, right? And we have 3 points and they have a name, right? So 0, 1, and 2. So what I can do is drag out a blast node, which actually deletes the geometry. There we go. So it has deleted everything. But over here in the group tab, if I type in 0 and press enter, you'll notice that the geometry or the point that had the name 0 is just gone. And if we take a look at the geo spreadsheet, now we only have 2. Well, you'd say, oh, here's 0. So what happened? Well, the 0 that was here, it got deleted. And now when we deleted, Houdini basically reassigned the names now. So yeah, that's what it did. So yeah, one geometry is deleted, but we don't want to delete geometry. We want to isolate it. Well, here in the blast node, there is an option called delete non-selected. So if I check that, look at that. And once that is done, let's just add a group create node, and we can just view this, and you can call it whatever you want at this point. And yeah, primitive group, why not? It doesn't really matter at this point. So I'm just going to call it 1, or yeah, 1. Wait, I don't think we can name it. It does have, but yeah, 1 is not a valid group name. So 1, how about now? All right, cool. So that is that. So basically we just have to duplicate this 3 times, and this one is going to be 1. So yeah, and then this one is going to be 2. So we have selected the point which has the name I think it should be, so here's 0, so it should be 1, right? So yes, 0, 1, and we've selected 1, and let me just duplicate that as well, and I'll type in 2. So all 3 of them have been isolated, so I've created a group over here, and then I'll just duplicate this and create a group over here as well, and I'll name it 3. Cool. So once this is all done, let's just all right. Oh, cool. I don't know what happened here, but basically I'm just going to add a merge node over here and merge all of these together, and then connect that over here to the rest of our thing. So now let me just quickly select them, hold A and drag to just organize them, right? And yep, so there we go. So now if we take a look on the, or if we just middle mouse click on the merge node, we have 3 primitive groups, 1, 3, and 2, with 1, 2, and 3, whatever, but we have 3 groups, and then these groups should be getting carried forward over here in the solver. So now if I refresh the solver or reset the simulation and middle mouse click, look at that, 103 primitive in this group. So 1 has 103 primitives, 3 has 103, and 2 has 103. So yep, job done. Look at that. And from here, what I'm going to do is again drop a blast node, which will again delete everything. But over here in the group tab, as you can see, we have 3 options. So if I select 1, it will show the it will basically delete the group with 1, which is all, it will delete basically all the primitives that are assigned to the group 1, but we want to isolate it like always, so hit delete non-selected, and let's do the same for the rest of them. So delete 1 over here and select 2, and again here the order doesn't matter, just do what it does. All right, cool. And now if we plug this boy right over here, and if I view this, look at that, this snake right here is smooth as fuck. And I'm going to duplicate this, connect that over here, duplicate this, connect that over here. And now if I were to merge them, so let's just select this, holding shift, select that, holding shift, and then tab merge. And if I merge them together, look at that. Woohoo! So that is what this whole thing is about. And obviously this is way smoother, and it actually is a bit, you know, it has finer details. And the reason for that is because in the VDV from polygons, we have the voxel size set to 0.01. So if I set it to 0.001, which was actually used in my original animation, as you can see, it takes a little while to think, and actually it was 0.05, I believe. Yep, so this one, right? And I mean, it's going to be a hassle to change it every time. So what I can do, what I'll recommend is to select one and do it all of the changes you want with it, and then just hit right click, copy parameter, and just paste it as a relative reference. So that way you just have to change it once. And yeah, I think this looks fine. So let me just quickly check what my voxel was. So it was, yeah, it was 0.05 in my original animation as well. So yeah, I'm just going to set this to 0.05, or actually 1, because I really want to record this tutorial. You may have heard my PC's fan going boom just a second ago. Right, so that's it. And another step that I'll recommend is, if you are going to export it to Blender, as I did, in the shading area, you'll probably want to isolate this, right? I mean, you can assign an attribute to it. I mean, a bunch of ways to isolate them, but what I ended up doing was adding in a CD node, the color node, and let's just view this, and I'm just going to select the color. No reason to dive deep into it. And I'm going to assign a color to it, which is going to be something nice, you know, like that, but basically bring it up, bring the saturation up. And then, yep, going to duplicate that, put that over here. This one, I'll choose something in the yellow zone. I mean, I'm not sure why I'm wasting time over here, but there is a point that I have to prove. All right, so this is for post-production sake. So just carry on with me, and that is too bad, too red. Yeah, there we go. So now if we take a look or middle mouse click on our merge, we have a CD attribute as well, and this will basically allow us to isolate objects in the shader editor, as I'll show uh, uh, in a few minutes. But basically, let me just disable this for now because it just looks bad. So basically, that is it for the tutorial, guys. Thank you so much for following along. So from this point on, I'd recommend just adding in a file cache node, which if you want to do any more post process to it, then I'd recommend adding a file cache node, saving this to disk, so that this animation will play a lot smoothly. I mean, it is playing smoothly right now, but that's because we have our voxel set to 0.05. So if you'll increase that, it will be a bit pain in the ass. But for those of you who just want to render this or basically just export it to Blender or any other software, just add a raw Alembic output. I ended up using ABC as the format. So here we have that, and yeah, render frame range. Let me just pull this out. Yep, so there we go. So you can see this. And yeah, just select the frame rate that you want to do that and select the output path over here. Make sure to use the .abc at the end, and once that's done, save to disk. And again, if you want I mean specific effect, you might want to go into the attribute Wrangle and change a few things. All right, so this is, I mean, slight change, as you've seen throughout the tutorial, slight change and the animation changes drastically. All right, so if you want more hugs or more folds, then you might want to mess with the pi value, you know, divide this by 2 or something, or even change it over here. If you set it to something like, let's just try something, right? So I'm going to go over here. I'm going to set it to 4 times 4, right? So select this, reset simulation, and let's hit play. Yep, just look at that. Look at the different, that is just beautiful. So yep, change values, mess around with it, and you will get so many different effects. And make sure to, like, if you make a change, just make it a practice to hit reset simulation on the solver. But yeah, so many possibilities out of this one. So what I'd recommend is, for those who followed along or those who are planning on making this, don't put in the exact values that I used. Please mess around with it and give me some fantastic results. My social media handles are linked in the description, so please do share your work with me once you're done with it. I would really love to see it. So now I think this marks the end of the Houdini part. So for those of you who actually want to take it to Blender, which is my native software, I'm going to show you how to basically do the rest of the thing in Blender. So yeah, so I'll see you guys there. Alright, so here we are in Blender, and yeah, this is it. So if you, whatever file format you have exported the file from Houdini, just go over here in Blender, import, and just import the file format. So OBJ, Alembic, which is what I ended up using, and FVX. So I think all should work. You may have a slight problems here and there, but you know, problem solving, that's the essence of it. ABC has always worked for me, so I always go with ABC. But other than that, yeah, you know what, let's focus on the shading part. So this is a old file of mine, but everything is the same really. So I will go over my render settings and the lighting and stuff later on, right? So let's just for now focus on the shader editor, which looks like this. So if you take a look at my original colors, they were like this, but they later ended up being something like this. So yes, that's why we kind of did the whole CD attribute thing, right? Because we wanted to have more control at the end. So what I'm going to do here in the overlays is actually disable the X and Y axis just for now, because I wanted to get this. Look at that. Where is my floor? Disable the floor. Look at that. There we go. And you would say that, hey, you could have disabled this, but when I disable this, I cannot draw. So that's why, right? So yeah, if I do this, look at that, I cannot draw over here. So that's why I need to do that. But either way, yeah, so the first thing that we need to do is add a color attribute, right? I think an attribute node will work just fine, but color attribute, well, it's just for color, and we have a CD attribute over here. So if I hit Control Shift left click, and yeah, so this is what we're seeing. And actually my 3D cursor is also, yeah, OCDs, gentlemen, OCDs. All right, so now, like I have said, if you are happy with this, just drag a principled BSDF, and you should be ready to go. So, you know, rendered, and it's looking fantastic. I mean, it's up to your taste, but me not so happy. So what I'm going to do is just drag this over there, right? And what I'm going to do is add a color ramp to this, and it only has a factor input. So there we go. So let's view it. And now our original image, it has some RGB values, but now with the help of the color ramp, it is now a grayscale image. So with that said, if I drag and, you know, drag these values over here, you can see that we're isolating just this one, right? And that's fine, but you know, we would like to have some control over there as well. So linear interpolation is what we're going with, or what is currently being used, and that's not exactly what we need. So what we need is constant interpolation, meaning it is either going to be 1 or 0, so white or black. So if I drag this white slider over here, you can see that we have already masked out this one, right? So this one. So what I'm going to do is, for demonstration purposes, type in 1 over here. So there you go, 1 is over there, and then I'll hit Ctrl Shift D to duplicate this while maintaining the connection, and let's just keep on isolating them. So if I just bring this over, right, you can see we are isolating. Okay, so we got one, but we would like to get rid of this, right? Or if I think I'm right, I can invert this and we should get a mask. But is it the same? Nope. All right, so that's cool. So we have 2 masks now. So one is this and one is of this. And explaining this, we have 2 whites over here and 1 black. So if I invert that, we have white and 2 blacks. So now we have these 2 masks. So now what I can do is name this to 2, which means this one is the third one. And this is just for explanation purposes, because I think I'm going to go and explain each and every step, which is, I don't know why I do that. You guys are smart enough as it is, but you know what? There are some people like me who are dumb. So RGB, so 3 tubes, so we need 3 different colors. So I'm going to add 3 different RGB nodes like this. So the first one I'm going to set it to something like, yellow. Second one will be in the blues, something like this, a cyan, yeah. And the third one will be a red, yeah, something like this, something desaturated. I like desaturated stuff. Yep, that was bad. So let's just select that. And all right, so we good. So first, well, simply, if we need to mix them, we just add a mix RGB node and we mix these bad boys together. And now if I view the node, you can say it's gray because it's the factor is set to 0.5. So if I take it to 1, we are getting this pink color, and if I take it down, we are getting this blue color. But now we have a factor here, right? Or we have a mask, right? Black and white. So if I connect this over to the factor, you can see that this pink color is getting it is getting assigned to our first tube, while the third and the second tube are getting this blue color, right? So that works fine. But now what we need to do is somehow even go deep into this and add the yellow color, right? So the way we're going to do that is even before this blue is mixed, right, we are going to make a few changes to it, and that's how we are able to assign 3 different colors. I'll just enough talking, I'll just show you how it's done, right? So currently we have a mask ready for the second one, right? So as you can see, this one, so we have a mask for the second one, and over here one is already, it already has a color assigned. So 3 and 2 it is what is lacking a mask for. But if you take a look over here, or sorry, this one, 2 already has a mask. So before the third input, so before this blue color gets fed into this mix node, if we add a mix node, right, mix these 2 and use this mask, which already has a mask for the second tube. So if I mix that over here and if I view it, take a look at that. So it is working just fine. The explanation may be a bit complicated, but what I would recommend is just play around with it. Okay, there are some things that the more you use, or the more you play around, you get this intuition knowledge, the intuition knowledge thingy, or intuitive understanding. That's what it really is happening. I mean, I can go and explain this 1,000 times, right? But I think every time I do that, I'll just complex more things. But basically, we have these 2 masks, and we're just using them to mix between these 2, and this color right over here before even it mixes into this. So before it is even enabled over here with we're just messing with that value using this mask right over here. So with that achieved, I think I can delete or erase these, and simply all you need to do is connect the base color over here, and we have that over there. And for the roughness, right, if you take a look at the original, there is some roughness over here, and I think I added a, so this one right here. So if I just duplicate that, and what I have here is simply a noise texture plugged into the normal of it, because since each frame it is getting since each frame has new geometry, so new geometry is created for each and every frame, so we can't really use object or UV. I mean, there may be clever ways out there, but you know me. And simply what you need to do is connect the factor to the roughness socket, and now if I view this, I think we'd have that roughness too. There we go. So now if I view the, take a look at the rendered mode. All right, so that is weird. What is going on over here? That's a weird thing. Let me check what's going on. All right. Okay, so that's weird. Let me quickly go to the material preview. Okay, so the material preview is working just fine, but with the principal BSDF we are getting some weird issues, and I wonder why is that happening. So material preview is just fine, but rendered view, oh, that's yellow and pink. So is it not, I think it is not respecting this. That's a weird cycle thing to do. All right, so I think it's the invert node that is fucking everything up. So I think what you need to do is go over here and play around with the values a bit. So what you can do is, with the inverse node, right, we inverted the whole thing. So to invert this, all you can do is just simply drag the blacks before the white, and I think you'd have another mask. It's not the same with this one, right? Yeah, it's just try to mess around with it. There we go. So that should be okay, right? Yeah, there we go. So I think it was the invert node that was messing everything up over here in the preview. Preview was fine, EV was fine, but the invert node was messing it up. So basically we did the same thing. We just inverted it by taking the whites over there and the blacks over here. So kind of in the opposite way, which is technically inverting. So yeah, if I go to the rendered view now, you can see it is, yeah, it is looking just fine. And again, these colors really are up to you. And now let me just quickly go and take a look. I'll just show you the render setting. Actually, I could have just kept the shader view over here. All right, render settings. I have my camera, which is this one. It is set to orthographic, and the orthographic scale is 1.54. Cycles GPU compute, and I actually lighted my scene with an HDRI, so really it could be anything. In my case, it's this Dresden Station Night 2K from Polyhaven. And I have a light here, which actually doesn't really help. I don't know why it's there. So let me just go to the rendered view. And this is the beautiful result that you get. So if I go and play it, look at that. It is working just fine. And yeah, quick tip, my bad. So quick tip, if you want to get this animation looping right, and if you did end up rendering the whole 240 frames, as we saw in the tutorial itself, we have to subtract one frame from it. So either you can do that in Houdini while you're caching, or what you can do is just subtract one from over here, and that way it will loop. So yep, I think this is the tutorial. So thank you so much for watching it. It means a lot for me, and I hope that you learned something. And if you did end up following along so far, I think it's been more than 1 hour, but yeah, so if you did end up following along, do send me the results. I would really love to see it. And again, experiment a lot with the values, as you saw in the Houdini part, right? Different values will get you different results. So yeah, that's it. Enough talking. Now it's time for me to sleep. Hopefully, yeah, it's 3 a.m. so you know, yep. Gonna go sleep now. So I'll definitely see you in the next one. So until then, be infinite.